Good morning, Year 8. Thank you for engaging with our online lessons again. Please send me that message on Show My Homework so that I can see that you've accessed the lesson, and then I can mark you down the register and give some reward points out accordingly for that. Today's lesson is going to be assessed by some self-marking, so there's a couple of quick exercises during the video itself, but the main activity is going to be a worksheet that's attached to Show My Homework. When you are completing the worksheet, then make sure that you are working through as many different question numbers as you can. So the A's, B's, C's, D's are just going to give you particular practice at a certain style of question. So as soon as you've got the hang of those, move on to the next number of question, and then you'll make much faster progress in the allotted time. And answers are linked to, so you can do some self-marking there. I'm still seeing a few people sending in work that isn't marked. Please make sure you mark it first, and then I can give you some feedback on the questions that you haven't got right, and you can make some better progress with that. Again, if you send any help messages to red@theroyal.school and then submit work via Show My Homework, it'll keep the two separate. So today we're going to be looking at percentages of amounts again, but increasing and decreasing this time. So our developing students are going to be able to calculate percentages of quantities. I'm going to show you a calculator way of doing it and some non-calculator methods as well. Secure students will be able to increase or decrease quantities by a given percentage, and then excelling students will be able to calculate a percentage increase or decrease. So I'd like you to write down here how you could calculate the given percentages of a quantity in a quick way. And if you'd like to pause the video until you've got the answers to these, we can run through those. So answers to this: 50% we should be aware is identical to a half with our fraction, decimal and percentage equivalent. So we could divide a number by 2. 50% is also the same as 0.5, so you can actually multiply a number by 0.5 to get 50% of it. Same way with 25%, you could find your 50% first by halving and then half again, or you could divide by 4 straight away because 25% is a quarter, or in this decimal multiplier way that we'll be speaking about later on, 25% is equal to 0.25 as a decimal, so you can multiply a number by 0.25. 10%, you can divide a number by 10, or of course this decimal version that we're on about quite often here, we could times by 0.1. 5%, you could find your 10% and halve it. If you're doing it mentally, you could divide something straight away by 20 because 5% is the same as a 20th, or we could multiply a number by 0.05 is another way we could do that one. 20% then, you could divide a number by 10 to find 10% and then double it to get 20%. 20 hundredths is equivalent to 1/5, so you could just divide something by 5, or this decimal version that yet again you could times a number by 0.2, and then 1%, you could divide a number straight away by 100 because obviously percentages are out of 100. So percentages are linked in proportion. It makes it really nice and easy for us to be able to find out complicated percentages by breaking them down and showing a little bit of working out. So if I started off with 28 as my 100% of an amount, we can use these quick methods to find out loads of different key percentages that might help us out with some more complicated working out. So I've moved downwards through these bubbles. 50% we said is the same as a half, so you can get 14. And then 25% is half of a half, or straight away you can divide our original number by 4, and that's going to give us 7. For 10%, we can divide a number by 10. And then for 5%, we can half our 10%, or we can divide our original amount by 20, and that gets us 1.4. And then to get our 1%, we could either take the original amount and divide it by 100, we could take our 10% and divide it by 10, or we could even take our 5% and divide it by 5, and that would give us 0.28. Now, if you can work out these key percentages, then you can piece them together in order to find some much more complicated ones. So if we're to look at a more complicated percentage to work out, here we've got 72% of 80. We can have a think which of those key percentages we would need in order to make 72%. There's loads of different ways of doing this, so your method might differ from mine slightly, but we should still end up with the same answer. So 72% of 80, well, we could get a 50% of it, so we've got a total of 50% obviously so far. We can add a 10% to that, that gets us up to a total of 60% of the number. Another 10%, we've got a total of 70% of the number, and then we can add 2 1%, and this will give us a total of 72%. So if we add up those key percentages that we've worked out, we'll end up with 57.6. So we can do the same with 38% of 64. Now, I'll leave this one for you to have a look at, so if you'd like to pause the video until we work it through, but do show some working out, especially if you're calculating these mentally. So 38% of 64, we might start off with 3 lots of 10%, and then we want to need our 8% then, so we could do a 5 and 3 ones. Add those together and we should have our answer of 24.32. So we can use those to piece together with our key percentages some more complicated ones. I'd like you then to have a go at these 8 questions please quickly, and then we're actually going to check our answers later on, but I'd like you to try this without a calculator please, so that you can show that working out in the manner that we did in that previous slide. So pause the video until you're ready to continue. I'm going to show us a slightly different way of doing our percentages, and we're going to use that to check our answers in just a second. So calculator methods for percentages. If we, for example, needed 46% of 90, we can pop this in the calculator, really straightforward and easy way, and we could think of our percentages as out of 100. So 46% of 90 is really asking us to find 46 100ths of 90. So we could pop that in the calculator as is. Now the way I'd like people to think about this is that I would like you to turn this 46 over 100 into one single number straight away. And this would be called the multiplier method. Remember, of in fractions means a multiply. So 46 over 100 of 90 means 46 over 100 times 90. And then we could put that as a single calculation, 46 over 100 times 90. And as I say, with this multiplier method, if you can do that as 0.46 straight away times 90, it'll stand you in real good stead for our upcoming lessons. And that would give us an answer then of 41.4. So a quick calculator way of doing percentages here. So if you could go back and check your answers using a calculator for these, and then I'll just run through the multiplier methods for them very quickly once you're ready. So number 1, we should have been doing 0.15 times 30. Number 2, 0.45 times 70. Number 3, 0.63 times 120. Number 4, 0.34 times 32, and so on, leading to question 8. So that'd be 0.645 times 48. You're obviously not going to have 2 decimal points, you can't have that in a number. So just convert it into its decimal first and multiply by it. We are going to move on to percentage increases now then. So we've got an example here. The value of Frank's house has gone up by 20% in the last year. If the house was worth £150,000 1 year ago, how much is it worth now? Now there's 2 ways of doing this. The first way harkens back to our previous lessons work, and maybe the previous slides. We could find out, well, what is 20% of this number straight away, and then because this is an increase question, it's gone up, we can see, so we're looking for an increase. We could just add that on to our original amount. So we could say that if we were after 10% of our 150,000, then we end up with dividing it by 10, so we end up with £15,000 is 10%, and therefore 20% would be 30,000, and we could add that on. 150,000 add 30,000 gives us £180,000. But that way is a little bit clunky when we get to more complicated questions. I'm going to show us a method that we're going to do in a single calculation here. And this is quite a nice way of doing percentages. We can draw some diagrams to help us out if we're struggling as well. It's a really, really nice way of doing percentage increases and decreases. So we're going to draw out a little visual bar model to show the value of Frank's house. And the original amount is always 100% in these questions. Now, with an increased question, this does mean we're going to end up with over 100% at the end. And when you're comparing something to something that has increased, then it is always okay to have over 100%. A few people will say that you can't have over 100%. They might be referring to like scoring a test or something like that. But in percentage comparisons, you can definitely have over 100%. So Frank's original house price is 100%, and we can see in the question there, it's still highlighted that his price has gone up by 20%. So we're just going to add that on at the end as another bar. So there's the extra 20% added on to the value of his house. Well, what we can see now that in the total of these 2 bars that we've drawn, the green and the orange, we've now got 120%. And that's the percentage that we're after. So we're after 120% of 150,000. So we can write that out as a single calculation here. Remember, percentages are out of 100, so 120% is the same as asking for 120 1/100ths of or times that £150,000. Now, if you're unsure on the fraction button on your calculator, you could always drop me an email, or you can just do this as two separate things. You could do 120 divided by 100 first, and then times by 150,000. But most calculators should handle this. And if you try out this question as well and get the correct answer, you'll know that it's working okay. So a single calculation now to get straight to our final answer, and that should give us £180,000. We did work out that before by doing the separate parts, but this is one single calculation and is therefore going to be a little bit quicker. Let's then have a look at some percentage decrease problems. These are really useful if you draw a diagram for. So here, example here, we've got a Bluetooth speakers which originally cost £75 are reduced by 30% in a sale. So what is the sale price? So we're now removing some percentage from the original price. This is one of the more common real life examples you'll see in the sales in shops for use of percentages. So again, we could go back to our sort of old way of doing percentages, and we could work out maybe 10% of 75 first, which is £7.50. We could multiply that by 3 to get our 30%, so £7.50 times 3 is going to give us £22.50. And then because it's reduction, we can then do £75, take away the £22.50 and leave us with an answer of £52.50. If you're okay with that method, fair enough. But again, I'd like to see that we could do this in a quick way rather than multiple calculations, and we can get straight to our answer. So again, we're going to show our original amount for this Bluetooth speaker as 100%. Now in this example though, we're reducing the price by 30%. So our other bar actually is going to cut 30% off it, which means that our leftover amount that we've got is our 70% here. So we're left with 70% of the original amount because we've taken away some of the price. So what this means is we're actually after 70% of our original amount, 70% of 75. So for our single calculation, remember percentages are out of 100, so we're going to do 70/100ths of or times 75. We can then do this in this single calculation, much quicker than our previous method, and this is going to give us our answer of £52.50 again. So hopefully you're going to find these methods much easier to do than you would doing working out the single percentage first and then adding or subtracting it to our original amount. But both methods are definitely valid, and if you really prefer one method over the other, then it's absolutely fine to be using that. But I'd suggest people do give the single calculation method a go, even if you've not tried it before, and you might find that actually you do like this method a bit better for percentage increases and decreases. I've got 8 questions then for you to try in your book before we move on to the main worksheet for today's lesson. As you can see, the first 2 questions have the bar model drawn already for you, so those should really help if you're doing the single calculation method. When I run through the answers, I will talk you through the single calculation method for these, because a couple of people do get tripped up on the increases and decreases, and that should leave you then ready for the main worksheet here. Whether you draw out those bar models for question 3 to 8 is entirely up to you, but it might be worth giving them a try if you struggle with the answers when you move on to that main worksheet. So if you'd like to pause the video until you're ready, and then I can give you the final answers and the working out for these as well when you're ready. Okay, on to answers then. So if you'd like to self-mark your answers that are shown in red, then we can talk you through what you need to be doing for these. So in question 1, we've got to increase 50 by 40%. You can see from the bar model there that that leaves us with 140% of the original at the end. So we need to be doing 140/100ths times by 50, and that'll get us straight to our answer of 70, as we can see. In number 2, we're decreasing 75 by 20%. Again, we can see from the bar model there that if you take 20% off our original amount, you're left with 80%. So we need to be doing 80/100ths times by 75, and that would give us 60. In question 3, we've got that increase again, increase 45 by 63, so we'd be end up with 163% of the original amount. So 163/100ths times 45 would get us our answer. In question 4, we've got that decrease of 67 by 37%. So if you take off 37%, you're left with 63%. So we need 63/100ths times 67 for that answer. In number 5, we've again got one of these decreases. So we're decreasing something by 14%. Now your original take 14 leaves you with 86%, so we need 86/100ths times 82 for our answer. Number 6 is back to an increase. So if you increase an amount by 24%, you end up with 124% of it. So 124 hundredths times 136 gets us to our answer. In number 7, we're decreasing something by 19%. So if you do 100 take 19, then we end up with 81% left. So we want 81 hundredths times 49. And then at number 8, we're increasing something by 56%. So we're going to have 156 hundredths times 88, and that'll get you straight to your answer. Again, as I said, if you went and worked out those percentages separately and either added them or took them away from the original, then you can still get exactly the same answers. Just you might find this newer method a little bit quicker. So this should be the main learning objectives completed now for this lesson. There's a worksheet attached from Corbett Maths for you to try and have a look at. So thank you for engaging with the online lesson. Please send me that message on Show My Homework if you haven't already, and I can mark you down on the register. Do make sure, please, that you are self-marking that work if you're sending it in. That way I can give you effective feedback. And then if you want any help, send it to red@theroyal.school and I'll give you a hand as quickly as I can. Remember, please, that when you're working with the Corbett worksheets, then the A's, B's, C's, D's are just more practice of the same style of question. So as soon as you're happy with doing the A's, B's and C's, there's perhaps no reason to do all of that question, and you can move on to the next question number. I think if people are feeling really confident, maybe 3 or 4 of each part before you move on would be absolutely fantastic. But if you do want that extra practice, then of course, please do more. But this way, if you're moving through the question numbers, you'll be able to make more effective progress in the hour of the lesson that we've got. Thank you very much. I'll speak to you later in the week.